we are group 7, and we're working on a herbicide dispersal, and as a warning, we've signed NDA, so we can't go into too much detail about what we've done, so it's probably not going to be as long as the other ones. As some background, in the knapsack herbicide dispersal industry, there's a lot of like inconvenient problems with, I guess, the user journey, particularly with like in the commercial industry. So we are working with a company that aims to target a lot of these issues, make the user journey a lot simpler, like more simple. Mainly pressure testing it. It is an ongoing program. It's been worked on before, and it's going to be worked on again afterwards. Sorry, this is our team. Myself, project manager, Regan's in charge of any mechanical manipulations. Assad is tied to electronics, and Marielle did all of our simulations. Next, please. So I think we can effectively break it down into 5 phases. Background research, planning the project, data collection, data analysis, and drawing conclusions. And the timeline at the top is not the timeline we followed, but the timeline that if we were to do it again, I would like to follow. So let's break it down a little bit more into those phases. Alright, phase 1, so background research. So this was what I spent the first few weeks doing, because we couldn't get access to the lab for a while. But mostly I was looking at the viability of the product, what issues the end users were having with the current products on market, which were a lot, and what issues we ought to prioritize, take care of, to simplify the use, I guess. And also, like when you look at any project, you want to look at any other companies that might be doing similar, any potential competition, and keeping in touch with the client as well, just to make sure we have our priorities straight. In terms of planning the project, this is where I think we lacked a little bit. If we'd spent more time on here, or if we had more time to spend on this, then I think it really could have excelled a little bit more. Yeah, that's just a very generic list of everything that people do, but I think scope was probably where we struggled, especially actually going back to project 6. I think identifying our scope, what was in scope, what we could do realistically, that's probably what led us down on that one. Alright, so data collection, this is what we mainly did in the lab. Effectively, we were just pressure testing the system that we had. We put a high priority on safety, putting time into creating P&IDs and standard operating procedures, or SOPs, and constantly updating those, making sure that the team's really comfortable with that, and what valves need to be switched off in case of an emergency, because we were working with highly pressurized water and air, which can go wrong pretty quickly if you're not careful. And we actually had a lot of issues with lags and attachments, what do you call it? Oh, like, you know what I mean? Leaks, big things, yeah, you go. And while we were doing that, Marielle was running, sorry, you're over there before, it's just simulations in the lab. Yeah, that's just a summary of that. Alright, data analysis. So we didn't have a lot of time to do data analysis because we didn't have a lot of data in the lab, because actually there was some discrepancies. But we created hypotheses using what we knew about fluid mechanics, and then using programs such as like MATLAB, ANSYS, and CAD at some points, we were able to confirm or deny those hypotheses, or that's what we're planning on doing for the next couple of days. Drawing conclusions, phase 5. So this project's going to be continued. Or might be turned into a capstone potentially, which Marielle might continue. And we did not accomplish nearly as much as we'd hoped. But that's okay because we have recommendations for the people going forward. Yeah, I think we've got a good starting point, and we've got, we developed an understanding, so that's alright. Alright, in hindsight, what does it say? Yeah, time was our major constraint. Really, realistically, we only had 5 weeks together with the whole team. When Project 6 was cancelled, we all came together, so we had 5 weeks as a team, only 3 of which were in the lab. So we really didn't have enough time to do everything we would have liked to. Particularly in developing the skills that we needed. So we all had like a lack of expertise, but we didn't really have time to develop that. Yeah, again, if we had been better prepared for phase 2, which was planning the project, we could have maybe been more organised, got further, but yeah, that's alright. Anyway, Rika, you take it away.
Alright, so for my part, my contribution towards this the project was doing some of the CAD work. As you see here is a part that I made, considering the parts I put together for assembly. This part here is a connection. I can't say much about it, but it might something about yeah, if not to be honest. But that was a part of the pressure, like, you know. But one of the things that held us back from actually making this part was that it couldn't be 3D printed. Initially, I wanted to 3D print this piece, but because of the dimensions, if you look, they're quite small. So the 3D printer couldn't like couldn't print that small, so we couldn't be able to print that. So we had to like make it up like different parts putting it together. So we put different like valves together to make that exact part. After this project, I didn't pay a big part of this project compared to the second one, where I was project manager. But for this one, I learned how to listen carefully to all instructions given by the professor to ensure that the data on the experiment was accurate and consistent with the trend that we were expecting. While I was doing this, the tasks that were being collected did not match up with the trend that we were expecting. This has its place on this. Overall, my main contribution to this project was mostly focused on helping with the collection of data inside the lab.
Hello everyone. I have assigned to do the pressure, to program the pressure sensor to measure pressure in the experiment, and the image analysis using MATLAB and other technical stuff. So as you can see, there's a pressure sensor. That picture shows the pressure industrial transducer sensor, which is connected to Arduino, which is displayed in the screen there. The pressure sensor has 3 pins. The first pin is analog pin. The other one is high voltage pin, and the last one is like ground pin. The Arduino has analog read function that converts the voltage value between the range of 0 to 5 volts to a number between 0 to 1023, which represent 1024 analog values. That analog values we can use it to measure the analog value for a specific voltage from this simple equation. So if we know that 5 volts equal to 1024 analog value, if we want to know 0.5 volts equal to x, so then do cross multiplication and get the value of the x, which shows there x equal to 102.4 at 0 PSI. This is the minimum value for the analog pressure at 0.5 volts. We do the same for the 4.5 volts. We get 921.6 analog pressure at 100 psi. Then we take the analog values and apply it at the pressure equation to get the pressure in psi, which equal to analog value minus 102.4 multiplied by 100 divided by 921.6 minus 102.4. mentioned before. At 0.5 volts, pressure is 0, and at 4.5 volts, pressure is 100 psi, which shows a linear relationship between the pressure and the voltage. This picture here shows the code that was implemented. First of all is implementing input for the pressure. Then at 102.4 it shows the pressure at 0 psi, and 921.6 shows the pressure at 100 psi. This line of code here, just to make sure that the value is in decimal place. This is the analog function that I have mentioned before, and this is the equation.